The first skill we worked on is knowing how to like expand. So if I give you 2 bracket x plus 3 bracket x plus 2, you guys are good with that. Hopefully. And you can expand like say a x plus 2 next to an x plus 3. Just means you got to do the whole FOIL thing. Does that make sense? So that's one skill that hopefully you're getting better at. The opposite of expanding then is being able to factor. And factoring has a really good use, and I'll go back up to the slide here. Factoring is useful when you're trying to solve. Hypothetically, let's say this thing was equal to 0, like I made it down here. If you can factor and put it into 2 bracket things is not the official word. Do you guys know what the official word is for like this? It's called a binomial. You've ever heard that term before? Bi, 2, nomial, numbers. Anyways, if you can make 2 binomials, then you can get your 2 answers like that. Does that make sense? So that's what we've been working on recently. However, there is a problem. What if you can't factor? Now, I don't mean like what if you're not capable of factoring, like you're not smart enough or you make a mistake. I'm saying like what if the answer, like what if the quadratic just cannot be factored? And that happens lots. Okay, let me just make up an example here. Let's say I gave you x squared plus 9x plus 1001. 10,001. If I asked you to factor this, I'd be asking you to look for numbers that add to give 9 and multiply to give 10,001. I don't think there's a lot of numbers that multiply to give 10,001. And even if there were, chances are they don't add to give 9. Does that make sense? So this is a very realistic possibility, and it comes up, to be honest, quite frequently. The questions you've been solving so far where things the questions you answer so far where things do factor, those are the nice ones. So I hate to break this to you, but like everything we've been doing up till now, those are easy. This is what's more or less typical, because chances are it's not going to be like a whole number. Does that make sense? Often x is either 5 or 6. But what happens if x is 3.9724137? Like an irrational number. Does that make sense? So here's how we go about solving this. I'm going to show you guys something called the quadratic formula. And as a formula, it will always work. One of the issues with this, though, is that I'm just going to tell you what the formula is, and you're going to kind of have to take my word for it that it's true. Okay. Later on in the course, once we learn a few more things, I'll actually show you how this formula was developed. But is it okay for just right now that you kind of say, okay, I trust you if it works, and then later I'll show you why it works? Is that okay? So here's just a couple examples. Let's just practice these then. How would you factor this guy if you could? What are you looking for? Well, you're looking for numbers that add to give 5 and multiply to give minus 6. Remember, the 3 and the 2 have to go together to give that minus 6. Do such numbers exist? I always like to do the multiply one. I think that's the easier one to narrow it down. So things that multiply to give 6 are 2 and 3 and 1 and 6. And one of those has got to work, right? 1 and 6? Like that? Perfect. If these numbers exist, you should be able to factor it, which means you should be able to solve it. Does that make sense? I'm not going to solve it, but does that make sense that you probably should be able to from here? Okay. Well, what if I change it? All I did is I changed this last number here by 1. Well, now we're looking for numbers that still had to give 5, but now multiply to give minus 9. Just going to put a little note here. These numbers exist, so factor away. Do you guys get the point I'm trying to make here, though? You can't find numbers that add to give 5 and times 2 minus 9. It just don't work. So need new formula. The first thing I'd like to let you guys know about this formula that we're going to show on the next slide here is that it will always work, by the way. Even if something can be factored, you could still use the quadratic formula. So a lot of students sometimes just default to the quadratic formula if they want. The only downside is it's very long. Yeah, this is the quadratic formula. Yeah, it's like, now at first it does not look nice. I promise you, by the time you've done this 20 times, it'll be easier. But like at first, it is intense looking. And so same thing I just said there. If it's okay with you guys, I'm just going to tell you this is the quadratic formula. I'll show you how to use it, and we'll talk about the why a little bit later. Sometimes it's just easier just to go with the how. So it's a little weird. There's a lot to it. So let me see if I can walk you through this. What you need to do is get a quadratic in what's called standard form. Do you guys remember the term standard form? A standard form basically means you have a certain number of x squareds, you have some x's, you have some c's, and you make it equal to 0. I've been making you guys do standard form all the way along. The way the formula works then is whatever coefficient goes in front of the x squared term, it has 2 spots that you fill into the formula. It gets filled in right here, and it also gets filled in right here, whatever that number is. Like it'll be the number 3, or 7, or -5. I'm going to use colors to help keep track here. Likewise, whatever coefficient goes in front of x, it also has 2 locations in this formula. One of them is right here, and the other one is right here. And you guys probably guessed the last part. Whatever the constant term is, the very, very last term, the one that has no x's, it has 1 spot that you plug it in, which is right here. Does that make sense so far? Like any formula, you basically have to plug numbers into the formula. Some of them you plug in twice. That's not the hard part. The hard part is then, how do you then deal with the fact that there's a plus and a minus sign, and a square root and a fraction? So I would say probably the best way to learn this is I'm just going to do a lot of examples. So I think I should have some on the next slide. Have I ever talked with you guys about the term roots, or have you ever heard that before in math? Okay, in case you have or haven't, roots is just a fancy way of meaning solve for x when y is 0. We're not doing anything different, just so you know. I want to show you new terminology in case you ever get a question like this. Not so much because I'm going to test you on this, but because maybe another teacher would. So, roots means solve for x when y is 0. This is actually really useful though, because don't I want one side of the equation to be 0?
So in this equation, x or y would just be 0?
Exactly, yeah. So if I give you an xy equation, you guys might probably have had those before, right? Xy equations. It just means make y equals 0 and solve for x. We're not doing anything crazy different when I use that terminology. So let's say we tried to factor this. We'd be looking for numbers that add to give 7 and multiply to give 2. Do those numbers exist? Hence the reason why we have this lesson. So the quadratic formula, by the way, is, I gave you guys a formula sheet, right?
Yeah.
It should be on there. So you don't have to memorize it because it is complicated. But once you get the hang of it, I promise you, it's not that bad. So here's how it works. It's negative b plus over minus b squared minus 4ac all over 2a. That's the formula. And what that equals is x. What are we trying to solve for? X. So essentially we need to plug some numbers into this thing here. So I'm going to start by leaving it as a negative and then plugging in whatever b is. B, this is going to be that 7 right there. Does that make sense? So start with negative 7. We actually use b immediately again. It's just how this formula works. Only now, rather than it being 7, it's now 7 squared. So far, so good. Then we have to plug in a times c. So it's like 4 times the a value, and a is whatever's in front of the x squared terms. So in our example, that's 2. And we also have to times by c, which is the only number we haven't used yet, which is That guy over there, the 1. And all of that is divided by 2, and then we re-times it by whatever the a value was, which was 2. Okay, that's the easy part. That is a number. Like, the number is going to be 9.7253. It's going to be some stupid, ugly number, but that is a number. Does that make sense? Our goal is to try to simplify it so that we can recognize that number a bit easier. So here's what I'd recommend. Actually, technically it's 2 numbers. Have you guys ever seen this plus over minus notation before? Okay, so what it means is that you actually get 2 answers. Okay, the first answer is going to be minus 7 plus this mess right here, divided by 4. And then the second answer is going to be minus 7 minus this mess, divided by 4. You guys know how when we were doing quadratics, we sometimes got 2 answers? This is how it actually ends up working that way. The plus or minus actually causes it. So you actually are going to do work kind of twice. Let me get to that, though. Everything under the square root sign should just be a number. So if you have your calculator nearby, find me what 7 squared is minus 4 times 2 times 1. You might even be able to do that in your head. Like 7 squared, 49. And then 4 times 2 times 1. Ignore the negative. Just go 4 times 2 times 1. Okay. So then if this guy right here is 49 and all of this is 8, 49 minus 8 should leave you with... Okay. Can you square root 41? Not nicely. Right? Like it's not like 9 or 16 or 36, like an actual square rootable number. And then last step, what's on the bottom of the fraction? 2 times 2 is... Okay. This is how we're going to leave our answer. It's kind of ugly. Most people don't like leaving it like that, but let me show you why I want you to leave it like that. If you wanted to actually find out what the actual answers are, you might do this in your calculator. Minus 7 plus root of 41. I would press enter at that point and then divide it all by 4. One of your answers for x is negative 0.149218, etc. Do you guys remember why I don't like you to write it like this?
So we can just add it at the end of the or
Yeah. The reason being is that this is a stupid number. It's an irrational number that will never end, and at some point you're going to have to round, and when do we even know when to round to? So honestly, writing it like this doesn't actually add anything extra to our answer. Does that make sense? There's a second answer, by the way. I should also do minus 7 minus the square root of 41. I would put those two things together and get the top of the fraction, and then divide by 4. So here are my 2 answers. The quadratic formula is useful then when the answers aren't 5. That makes sense? If it was a whole number, you probably could have factored it. If the answer was going to be a stupid decimal number, that's what this was developed for. Okay. But don't do that. There's no point to it. Like, you can, but I don't require it, and I don't know how it helps, other than it just tells you what the decimal numbers are. Does that make sense? One more thing here. Let's actually test our work then. Okay. Because maybe you don't believe me. You're like, okay, this is just magic. Right? Well, let's try one of these numbers here. This right here was my answer. Have you guys ever used the answer button on your calculators? Like go second. I screwed that up. Second entry. No. Shoot. Second answer. Second answer. No, that's not it. Second enter. Second enter. I guess I'll just do this by hand. And then divide by 4. Okay, so there's my answer. Have you guys ever seen how to do this? Like 2 bracket answer squared plus 7 answer plus 1. You guys ever seen how to do that before? Okay. What I'm doing here basically is rather than like rewriting this negative 3.35, this number right here, if it's literally the last thing that my calculator calculated, I can just go second negative sign and it'll pull up that number. What should all of this hopefully equal when I press enter? Yeah, 0, right? Because way back here I told you that 2x squared plus 7x plus 1 is supposed to equal 0. So if x truly is an answer, it should equal 0. That makes sense. Some calculators, if you guys have newer ones, you can go back up and find an old answer and pull it back down. Mine doesn't do that, unfortunately. So I'm going to do the other one real quick. If I go minus 7 plus root 41 and then divide by 4, my other answer was this guy right here. So we try the same thing. 2 answer squared plus 7 answer plus 1. And if you guys have calculators that go back up, you can literally go back up and actually just like select that number. Yeah.
What if you can't square root what's under the square root sign?
I'm going to show you an example in a bit. But that is actually a possibility. Do you mind if I just hold up on that though? Okay. Does this make sense then, the idea that you should be able to check your work? Okay. Long story short, quadratic formula is usually designed for stupid numbers. So again, rather than writing it as decimals, write it like this. So far so good? Cool. Okay, let's try another example. Before I do that, what was this slide on here? Oh, okay, yeah, the point here. I prefer exact values myself. And I would say probably most math teachers do as well. Finding that decimal number is not purposeful. So don't write it like this. Leave your answer like that. It's going to look stupid, but it is a number. Actually, it's two numbers. Actually. Okay. Should we do discriminant right now? No. Let's try a couple of these examples here, and I'll come back to the slide I skipped. I don't think I want to talk about it just yet. Let's do one more example. Let's try the first one. How about I do the first one, and then maybe I'll have you guys try the second one. So, if we're trying to find roots of a following function, it's just a fancy way of saying make 0 equal negative 2x squared plus 3x plus 8. So we're solving for x. Chances are we're not going to be able to factor it. If I'm asking you to use the quadratic formula, probably doesn't factor. So, formula is negative b plus or minus b squared minus 4ac all over 2a. So first step, you've got 5 numbers you got to plug in. A couple of them twice. So you need a negative 3. Then you need 3 squared. You need 4 times negative 2 times 8. And on the bottom you need 2 times negative 2. I'm using x's as times signs. Would it be okay with you guys though if I use dots instead? You guys know that notation? I don't usually like to use dots or time signs because they look like x's. To be honest, actually, my preferred way of doing this is actually to put everything that's needing to be multiplied next to each other in brackets. I actually prefer that best myself, because otherwise a dot might look like a negative sign. And anything you can do in math to prevent mistakes is, in my opinion, a good idea. So I personally use brackets. So, okay, the negative 3 that's out front is just negative 3. I don't really do much with that. All of this stuff underneath the square root sign, the slide that I skipped, there's actually a name for it. We call it the discriminant. And it's often really useful just to kind of find what is all of this mess of stuff right here. So, 3 squared is 9. What's 4 times 2 times 8? 64? You got a calculator? 64? 64. Okay, now what I recommend is just timesing the numbers together and then just consider how the negatives work. You have a negative and a second negative. Double negative really means like add. So we need 9 and 64. So hopefully by the time you're done you got 73. Again, can 73 actually be square rooted? No. If it could have been square rooted, it probably could have, we could have factored to solve. That makes sense? So like if this number here was 16, you probably could have just factored. And then last step, over negative 4. We're done. No, that seems kind of odd, but this is two numbers. They're decimals. They're stupid looking. We call them irrational. You guys know the word irrational? Like, they're never going to be able to be rounded nicely. But there's our answer. Does that work? All right, cool. Why don't you guys try the next one then? So that'll be 0. I think I should pop in for a second here and point something out here. You guys see how the b value is negative? There's actually two main things you got to be careful here. When you put b in as negative 4, negative 4 actually makes it positive 4. Does that make sense? So like you can start by just calling it just regular 4. Sorry.
How did we get 73 in the square root?
Was it 73 or was it 70? Did I screw up my math? It was.
Yeah, because it was 64 is negative 4 times 8 equals 2.
Yeah, it was 64 and 9, right?
Yeah.
64 and 9. Isn't that 73?
You add?
Well, it was a double negative? Because I think it was 9, and then it was like a minus 4, and then a minus 2, and a minus 8 or something like that. So like the double negative means you should add.
Well, the double negative will just be that this is completely positive, and then you just add.
So like, let's say that you ignore this negative side right here. Then 4 times negative 2 times negative 8 would be negative 64. But then 3 minus negative 64 really means you're adding.
Oh.
Does that make sense? What I like to do is I just do this. I just do 4 times 2 times 8. Ignore all the negatives. And then say it's just 2 negatives. Add. If it was not negative, actually subtract. If it was somehow like, say this was negative 4 negatives, negative 8, or minus 3 negatives, and you're back to subtract.
I got that.
Y equals
Plus or minus. Square. Oh wait, I didn't.
It's 2 times 4.
Wait, hopefully you guys got this when you plugged all your numbers in. Again, that's probably not the hard part. The key is this thing under the square root sign. The discriminant is what we call it. You have to simplify it a bit. What's negative 4 squared? Positive 16. The most common mistake I find kids make here is they forget that negative 4 squared is actually plus 16. Make sense? Now, if you type it into your calculator, you got to be smarter than your calculator. Let me show you something here. If you go negative 4 squared, your calculator will actually call it negative 16. Here's why. What your calculator thinks you're asking it to do is bed mass. You guys know that acronym? Okay, so B is brackets, you have no brackets. The next thing is E, exponents. You do have an exponent. So what your calculator did is it did negative 4 squared, or no, it just did 4 squared first, and it ignored the negative. Because really, a negative is like a subtract. Does that make sense? And so it did the subtract last. So it did 4 times 4 for 16, and then said, okay, now make a negative. What you really wanted to do was go bracket negative 4 squared. Because now what you're asking it to do is take the whole negative 4 and square that.
So anything that's a negative that's like squared is always going to be
Should be positive.
or positive.
Yeah. So just make sure that if you type it in your calculator, you're really careful there. So ultimately, this whole thing becomes 16. But you know what? This whole thing right here also becomes 16. That makes sense? So what you're left with is 4 plus or minus the square root of 0 over 8. Okay, this is probably something we could have factored. Because if you ever get like a whole number right here that's actually something square rootable, you probably could have factored. What's the square root of 0? 0. So if you take 4 and you add 0, or you take 4 and you subtract 0, does it actually affect anything? Okay, so what you're really left with is 4 over 8. So the final answer is 1 over 2. There's actually only one answer here. Curiosity, did anybody manage to get it all the way to the 1 over 2? Okay, I would say, know how I normally said you can kind of stop here? I have one like addition to that though. Stop there, but only if like the square root sign can't actually be like square rooted and something is done with it. So don't stop here on this one. You can actually simplify it to 1/2. Does that make sense? Okay, let's try the next one together. Alright, so what are we looking for? Negative b plus or minus square root of b squared minus 4ac all over 2a. Wait, don't miss the double negative again. Because this is a negative 5, a negative 5 means we're starting off with this normal old 5. This negative 5 that gets squared, I'm just going to throw it in a bracket so that I don't mess up that negative bit. 4 times 3 times 9 all over 2 times 3. More room here. So far, so good with just plugging numbers in. This is probably one of the things that confuses my math students when I start off with them the most. What's going to happen at this example here? What happens when you square negative 5? It becomes positive. You're going to get positive 25. I'm just going to write that over top here. Who's got a calculator? 4 times 3 times 9. That's got to be 12 times 9, so 108. So you have 25 minus 108. I don't actually know what that one is in my head. I'm going to actually do that yet? 25 minus 108? Okay, we have a problem here. You guys have some experience with square roots, I hope, right? Can you actually square root a negative number? Negative numbers cannot be square rooted. I don't know if this is a fact you guys know, but by definition, a square root is a number that when you times it by itself, that's the number you get. There is no way to times a number by itself and have it be a negative number. Here's how. Let's say it's a positive number. A positive times itself, which is also positive, would be positive. A negative times again by itself, which is negative, would become a positive. So therefore, working backwards, you cannot square root negative numbers. This is the thing that will confuse students probably the most when I start with. Here's the answer. There is no answer. In math, this may sound crazy, but sometimes there is a problem, and the solution to the problem is it is an unsolvable question. And I think a lot of students, when I teach them this at first, they get confused going like, this does not mean that we're incapable of solving it, or that we made a mistake. Sometimes the answer is, we can't solve this problem. Let's see if I can give you a good example. You guys know football?
Yes.
Basic rules. Field goals worth 3. Touchdowns worth 7. Let's say you're down by 10 points. There's 1 second left, and you want to throw a Hail Mary, try to score. But you're down by 10. Can you win the game? No. The best you could do is get 7 points, but you'd still be losing. Does that make sense? Sometimes the answer, there is no answer, is true. And I mean, maybe that makes sense in a sports analogy, but it also happens in math a lot. Where if I ask you to solve for an x value that would make this equation true, there is no x value that could somehow make this work out for you. And in real life math type problems, sometimes that's the case. If I did a statistical analysis and said, I want for you to somehow make $100, And in order to make $100, you're working at $5 an hour, and you can only work for 3 hours. Well, how can you make $100 if the limitations are you're only making $5 an hour and you're only working for 3 hours? Does that make sense? So, and it's a weird concept to wrap your head around, especially after the last 11 years of your life you've been told math always has an answer. That's what makes it nice. Sometimes the answer is there is no answer. Does that make sense? It's frustrating. It's kind of weird, but it's nice actually, because at this point here you can just stop. If you get a negative under the square root sign, it actually I just want you to write a sentence or just a quick thing there that says, can't solve this. Not, you're not smart enough to solve it. Not, I'm holding out on you. Sometimes the answer is, this is an unsolvable problem. Does that make sense? Maybe you've heard of the term like a no-win scenario. Oh, sometimes there are no-win scenarios when you're using math, where just there's no way to act. There is no outcome that makes you win. Maybe like chess would be another good example. You guys played chess at some point in your life before? Like when you're in checkmate? So you're like, okay, maybe I'll try moving here. No, that won't work. Maybe I'll move here. No, that won't work. Sometimes the solution is there is no winnable solution. So let me go back to that slide I skipped now. This discriminant right here then will tell you how many answers are possible. It is possible that there's more than one right solution. So if you like my analogy of like winning a game, there might be more than one way that you could win your chess game. You can move your king here, or you can move your king here. Maybe there's more than one right solution. Maybe there is only one solution that works. Or maybe there's a possibility that you can't win. It's no longer theoretically possible. Okay. And so here's the 3 ways you can answer a question. If this thing under the square root sign is bigger than 0, there's more than one way of solving the question. If the stuff under the square root sign equals exactly 0, there's actually only one solution. And if the stuff under the square root sign is somehow less than 0, you guys know this notation, the greater than and less than? Okay. If it's less than 0, it means it's a negative number. It means there is no solution that makes this work. Fundamentally, this is a brand new way of approaching math. Maybe it's not. Maybe I'm overthinking things. But normally when I teach kids, this is like groundbreaking. Where it's like, there's not just one answer for x. Now there's 2 answers for x. And eventually we'll get to math where there's 3 or 4 or 5 or 6 answers for x. And again, if you like extrapolating that to everyday life situations, sometimes there is more than one way of solving a problem. Right? Maybe there's 6 correct solutions that could make it so that I win my chess game. Maybe there's one way that I can win my chess game. Does that make sense? Or maybe we're at the point where doesn't matter what I do, I'm going to lose. So there's 0 right answers. By the way, I should point out, no real solution does not mean the answer is 0. It just means there is no answer. Because like the answer is 0, x equals 0 is actually a possibility. Like sometimes x is actually 0. Does that make sense? So with that said, let's skip ahead. Let's try a harder question here then. So this should be something more similar to what we've been doing. How many more of these do I have? Is this like my last example? Second last one. Why don't I try this one, and then why don't we take a 5-minute break? And then after you come back from a 5-minute break, why don't I challenge you with the really hard one? Does that work? So let's just do one more as a group, and then we'll take a break. So we've been at this point before at some point in the last week and a half. What should we do to start? Yeah, FOIL. Untangle the knot. This is a mess. Let's make it nicer. So x times 3x is 3x squared. 3 times minus 5 is minus 15. I'm kind of going in a different order, I guess. 3 times 3 is 9x, and that's minus 5x. So far, so good. You may have those 4 in a different order, but hopefully you have those 4. The second thing over here, it's kind of tricky. Not only do I need to FOIL it, but when I'm done, I should times everything by 3. So I like to write it like this. I'm just going to throw a 3 out front, and then I'm going to use a big square bracket. And then I'll FOIL this stuff. So that'll give me 2x squared. That'll give me plus 5. That'll give me minus 10x. And minus x. The next things you do, you can do probably in any order you want. You could combine these like terms here, and then times by 3. Or you could times it all by 3 and then combine like terms. I don't really care what order you do it in, but let's see, that would be a plus 4x minus 15. And this would be a 6x squared. You'd have a 15 at the end. What is that, minus 11 times 3? So minus 33. I kind of put a couple steps together. Did that make sense, though? Did I lose anybody there? Okay, I've untangled my knot. Straighten it out now. So make one side equal to 0. It actually doesn't really matter which side you make equal to 0, but I have a personal preference. I like my x squared terms to always be positive. That's how I like it. So if I was doing that, I'm going to subtract the 3x squared from that side. I'm going to subtract the 4x and add 15. Because then this side now equals 0. This is what we've been doing for the last couple of days. Any issues with that? Okay. Factor it. No. I don't want to factor that. I mean, I don't even think it probably can be, right? Like, you're looking for numbers that add to give minus 37 and times to give 90. I mean, maybe those numbers exist, but why bother, right? This is why the quadratic formula was developed, to try to solve this sort of question. So, pull out that quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. By the time we're done, either there will be a solution, there could be 2 possible solutions, or there's the possibility that there is no x in the world that we could plug into this equation and that it would actually work. It's an unsolvable question. Okay, so negative b. B is negative 37, so double negative it, make it positive 37. Oh, this is gross. We got to do negative 37 squared. Don't forget, when you type that in to your calculator, if you're doing that, make sure that it's a positive number, because negatives and negatives are positive. 4 times by 3 times by 30, and then 2 and 3. I then recommend, let's try to find what this discriminant is here. So like all of this mess under the square root sign, let's figure out what that number is. It's either positive or negative or 0. So 37 squared is 1369. And 4 times 3 times 30 is 360. So 1369 minus 360 is 1009. Everybody else able to get that? Unless 1009 actually square roots, we're done. I doubt it, but I'll double check. No, it's a dumb, irrational number. Does that make sense? Okay, last step, and then we'll take a break here. We should be able to check our work. To check our work, let's go back up to the original question up here. It's very ugly. But what I'm going to do is I'm going to try to type in that exact value into my calculator. I'll just do it once, though. So, let's see. Let's go 37 plus root 1009, and then divide it by 6. That's what I'm going to use for my answer button from now on. And if you guys have a calculator that can go back up, you can just do that. So, our original question was to find an x value that makes both sides of these things equal to each other. So I'm going to go bracket my answer plus 3, new bracket, 3 times my answer minus 5. Make sense? 424.82529. And I'm going to do the exact same thing on the other side. That make sense? Okay. I can't go back up in my calculator unless I do this, I think. No, I can't do that. I'll have to retype it in. 37 plus root 1009 divided by 6. Okay, so then I'll try the other side of the equation. 3 bracket answer minus 5, 2 answer minus 1. And if everything works out properly, that number right there should be the same as the one I got on the other side. Does that make sense? Okay, quick summary, then we'll take a break. Goal of the quadratic formula then. Solve harder problems. But with harder problems comes more complex scenarios. There could be more than one right answer. There could be one right answer, and then the most tricky one. There could not be a right answer. And that's the one where if you can wrap your mind around that idea, that's going to happen a lot over the next, I guess, year and a half of doing math. There's more than one answer. Sometimes we might have 10 answers. Sound good? Okay, go take a 5-minute break here. When you come back, really all I've got left is a really challenging question. So why don't you guys try that when you come back and then see how far you get, and I'll come wander the room.